So consider the Ferris wheel passenger situation. On the top, there's the radial acceleration. Assuming we're going clockwise, there's a speed or velocity, tangential velocity, that is to the right, and then the mass of the person. And then as it rotates, we reach the bottom. The velocity is to the left now. The acceleration is still radial because we're going in circular motion, and the mass is still there. Assuming that the Ferris wheel has a radius r, then we know that the acceleration is v squared over r. And if we look at the top situation, then if we consider the passenger, then there's a seat that's pushing the normal force, pushing the passenger upward, and there's the weight of the passenger downward, and the acceleration y is pointing in the negative direction. On the bottom, we have a similar situation. Let's call this Fn on the top. On the bottom, we have F sub n on the bottom. We have the weight, and we have the acceleration y, but in this case it's going upward, right, as the pictures first say. So let's look at the top case, and if we do the sum of the forces in the y direction equals ma, we're going to get that we have the normal force on the top minus the weight equals the mass times the acceleration in the y direction. And if you recall from the top part, the y acceleration is negative, so this is going to be normal force minus the weight, which is mg, equals minus m times v squared over r. And this means that the force normal on the top is going to equal, if I move the mg over, I get mg minus mv squared over r. There's a trick in math where if we can take an mg out, we get 1 minus v squared over gr. That will give us the same simplified version of the force normal on the top. And if we do the same thing for the bottom, and we do the sum of the forces in the y, so this is for the top. Let me adjust my screen again. And this is for the bottom. Sum of the forces equals ma. We get the force normal on the bottom minus mg again, the weight, equals m times a, but this is a positive v squared over r. And again, if I do the same thing as I did before, f normal bottom would equal mg plus mv squared over r, which equals mg1 plus v squared over gr. So now we found the expressions for the top and the bottom, and you can see that the main difference is that one of them is a minus sign, one of them is a plus sign, because the acceleration is negative or positive at that point.